One kind of scale for weighing trucks can measure their weight as they drive across a plate. However, it is not known whether this method is equivalent to the traditional method of static weighing. Find the 95% confidence interval of the weight differences. Interpret this interval in context. Okay, so let's go ahead and click on the icon to view the table of weights. I'm going to go ahead and open this up in StatCrunch. I usually look at it. We have weight in motion and static weight, and then they did static minus weight in motion. Okay, we have a couple options here. We can go to stat, tstat. It is paired, but they've already done the difference for us. So I could go to one sample, I have the raw data, and just select the difference static minus motion. We're not running a hypothesis test, we're running a 95% confidence interval. And press compute. And there we go. So we are in between negative 0.91 and 2.6. Or let's say they didn't have this difference, and often we don't have the difference. They kind of helped us out almost a little too much there. I'd go to stat, tstat, and just go ahead and go to paired. And I select my pair. I could save the differences, so we create a column of differences. I'll go ahead and run the confidence interval and press compute. So notice what we have here. Here they did mu1 minus mu2. So they did weight minus static. It doesn't really matter. The intervals are really going to be the same. They've ends up switching mathematically. It switches the positives and negatives. Ultimately, though, our conclusion is going to be the same, as you'll see just in a minute. For the purposes of this one, though, since they gave us that difference we would need to know, I can always go back and edit that difference and switch. So this one will always do mu1 minus mu2. So I went ahead and put the weight static. So I'm going to do static minus weighted motion. And that'll get us back to the same one. Okay, we're going to interpret this interval. So we're 95% confident that this interval contains the true mean. This one here. Now, I wish I'd ask us a third part, and that since 0 is actually in my interval, I can be 95% confident that there is no difference between these two methods. If 0 were outside of that interval, then I wouldn't be confident that the methods were the same. So I hope that helps.